Ponnani where we could go for study tour. So there are 2 study tours. So that fascinated all of us. Frankly, I mean, it is not because of geology or because of science. So what we learn from MES, these are the people who teach us. They had a hard time to control. You can see here, people use, faculty use gun to control students those days, believe me. And study tours were all very strict, field oriented. We were all good students, hardworking. We worked very hard. You can see some of the examples here. And this is what we learned because we never get time to get into the classes. We were all outside. And these 3 people worked very hard to make us come to the classes. Now I know why. Because what small things I learned was very important. I could have attended more classes, but unfortunately, I was very busy with other things. Then there is an account with MES now going on. So whatever I did in MES, so MES actually, there were faculty in MES actually giving back, or they know how to do it, to give back. So right from several people like Tanuja, Jesse, Durga, and Nidya is coming, is all from MES. So Tanuja is going to give her colloquium in a couple of days. Jasin was with me. He did his master's with me, and then he moved to Japan, took a MPhil. Then he came back, and now he is in Austria for doing his PhD. I know that he is in the audience. So I promised him that I will tell that he is in Austria. And with special request from people from Australia, they also want me to say that they are in Australia. So Durga and her friends are now attending the meeting, I know. So they are now in Australia. So she is doing her PhD in Australian National University. She did her master program with me, and now we have a joint supervision program where she is doing her PhD with Professor Ian Williams and jointly with me in IIC. And it's under a joint supervision program. And Nidya, again, she came from Ponnani, and now she is working on something very strange on glaciers. So she is teaching me what glaciers are.
You have a power failure or something? It is not audible now. It seems he has some problem with his computer. He mentioned it like that.
Hello? Hello, anyone?
You are back? Yeah, you are back.
Yeah. So
okay.
there is a power change of So one more time
Okay,
it will
okay.
come, I think, because now we are on generator, so it will come back again. It will go, and if when the power come back, I will be back maybe.
Okay, no problem. Yeah.
Okay. Yeah. So if I get disconnected, I will come back again. Sorry for the trouble. So you can see my slides, right?
No, please project it again.
Oh, you want? Okay. When you can see, please let me know.
Yeah, now it is coming.
Okay. No. Can you see that now?
Yeah, yeah, now it is okay. That background is
I
also.
will. No, no. I will change.
Yeah,
Yeah.
okay.
So I was talking about this. There is no surprise for me that why the power went off. So I'm talking about the one of the a group of people who make me like this. Okay. So you saw my previous photo, and now art teacher actually get my recent photo. So these people are mainly the reason for how I became like this. Okay. So now here comes the center person. So he learned everything. Basically, whatever do nots we did during our stay in MES, he learned everything from me. So I had a big loan to pay him back because basically I owe him a lot. So this is a very big inspiration for everyone also. At this age, suddenly he decided to do a PhD. And fortunately, I could help him to do the analysis in IIC, and he completed his PhD. He is also a brother of Srijit. So I don't know how Srijit took geology after Ajit. That is still a suspicious thing. And still, I was thinking like I should give back something, uh, like they changed me by this group of people who are in here. So I thought of giving some. So here you can see she's Adira. She PhD with
Not audible now.
I think that power has resumed right now, so he'll be joining.
Hello, I'm very sorry for the mess up. I will take extra time for that.
Sure, you can.
I mean, because there is some power issues going on in the campus. So this is actually the reason for because the major cable, incoming cable, having some issues. So, but we are supported with generator, but at the same time, you know, this changeover is taking time. So. Can you see my screen now?
Not yet projected.
Yeah, I'm doing it.
Yeah, it came.
Okay. So there is no surprise that power is going and coming because I'm talking about a group of dangerous people. So now I was talking about Adra. So Adra came to me along with Tanuja, and now she is doing her PhD with teacher, and she's also using my facility here. So we are collaborating one way actively with MES, and they are doing good. All of them are doing good nowadays. So she is working on beach places, which is also new for me. So I learn about beach places from Adra. So next slide is like okay. So what I learned after MES. So this slide is self-explanatory, and I hope you can see. See my slide. So these are the main points I learned after I leave from MES. So all these points shown here are what you can see, what I learned after my undergraduate program. So after that, hello.
Yes, it is clear.
So these are things I learned from my. These are the things I learned after leaving Ponnani, and then now what I learned from my students. So I have a group of very good students. So I told you I missed many of my classes in Ponnani, so I still survive. But after that, I show you a blank slide, so it means I don't learn much after that either. But after I start getting students, I started learning a lot. New things, because many of my students, they really don't want to work on things which I am working. They really want to work different topics. So if you see here, these are the first is a group of students who work on PhD problems. The next, some of them they work on a master program or undergraduate project. Then there are a lot of postdocs who work with me. Then project staff. These are actually the strength of my research for last many years. Especially if I take, say, for example, like George, Remya, Shafia, Ishar, Vinod. These are the first set of students who helped me to set up the labs. Among this, Ishar is now in IIT Kanpur, who is a faculty there. Then many of my postdocs are faculty in IIT Bombay. Shakti is in IIT Bombay. Amlan in Indian Statistical Institute. Saurabh in IISER, Mohali. Ratish in Kusat. So these are all very good. They are all in very good position, or they are getting into very good position these days. So many of my PhD students, they start working. Like one of my students who is working now, she is working on chromium bearing spinel or chromides, and it's metasomatic processes. Then he is working on that, and then Adira is working on beach lasers. So these are all like a fresh figures which they brought to me for discussion. I grabbed them and use it for the presentation. And now go to what more we know. So all of us know that southern India is divided into major cratons, 8 major cratons. This is a paper by Radish and others in 2009 in Technophysics. You can see that the biggest craton in southern India is Dharwad craton, and south of Dharwad craton is an area where you see a lot of granulates. We call it southern granulate terrain. But this granulate terrain is not connected to this. This granulate terrain is not connected to the cratons. So this is the problem when you are giving talks in your office, because anyone can call you directly to your landline. Anyway, so the southern granulate terrain is one of my focus area for my research for last many years. And why southern granulate terrain? Because most of the students who were there, I'm in a meeting, can I call you back? So if you look at the southern granulate terrain, this is the Dharwad craton, and the Dharwad craton is surrounded by several small blocks. All these blocks around the Dharwad craton, they are all metamorphosed in high-grade granulates. So this is called Karwar block at the north, and then a lot of blocks like Kur, Nilgiri, BR Hills, Shevaroy, Namakkal, Madras block, Madurai block, Trivandrum block. And what these boxes are? These boxes are all the PhD students who are working with me. See, if you look at the PhD boxes, if you see the Karwar block, hello? Hello?
Yes, we are hearing.
You can see a disruption on the screen or just the screen?
There is a pop-up, something popped up.
There is a pop-up, right?
Yeah.
So this is the network is not working anyway. So if you look at the boxes here, these two are the area where Ishwar did his PhD. Then Vinod, this is the place where Durga and George doing their George did his PhD, and Durga is now doing BR Hills and this gap here. Now BR Hills, my postdoc Ratish was working on BR Hills. Then in Madras block, very recently, Tanuja started working on Madras block. Recently, we published a paper from there in Lithos. Then Madurai block was my research interest during my PhD, followed by Shakya did a work here. One of my collaborator and postdoc, Rajkumar, worked on the easternmost part of South India, southeastern part of South India, and this long box is actually a collaboration from Kusat, where a student named Anusha, she is working here. Then we are also, Durga did her master project on KKB, and I also have other collaborations working on Kerala Conservation. So when I came to IIC, there was a great difficulty in finding a good map for Southern India. So one of my PhD students, Ishwar, he started working on the regional structural mapping of South India by using satellite images. So what he did is he delineate the lineaments of whole South India from Landsat imagery one by one, all the structural lineaments, and then we redraw the regional scale structural shear zones for whole South India. So most of these blocks or the outline or the boundary of these blocks are defined by a ISRO funded project helped by Ishwar a lot, started the working on all these projects. Now, once we started working on these projects, we find out this is very important to go to the field and check the field relation from all these areas. So what we could see here is these black dots are about 80% of the field locations, because I haven't incorporated many of the recent ones. So most of the South India we did field work for last 12 years. Most of my students did field work for, and the cluster points are all PhD work. And then this is the area where Adria started working on the beach places. Now, I will start with one by one of this block. We will first talk about Nilgiri. Sorry for that arrow, it should be here. So, Nilgiri block. Nilgiri is a block which is situated in the southern Grand Lake terrain, and Nilgiri consists mainly of Charnaka. But at the northern part of Nilgiri, if you go, you can see there are layer of metagabbro or garnet gabbro intercalated with metasediments or BIF. Then there are also metatufts at the northeastern part of Nilgiri and amphibolite. When you look at the rock type of Nilgiri, what you can see here, this is the garnet clinopyroxene bearing rock, which consists of garnet and CPX as mineral assemblage. If you look carefully, this is a micro CT scan of garnet CPX rock, where you can see there are a lot of porphyroblastic garnet with inclusions inside the garnet. This is a micro CT image of garnet. This is much more closer view. If you look at the thin section, what we can see, garnet and clinopyroxene is in equilibrium. So the garnet pyroxene equilibrium rock, where you get plagioclase as late growth along the grain boundary of garnet and CPX. There are also formation of amphibole along the grain boundary or along the cleavage plane of the sample. So the retrograde product of this sample is basically amphibole, which are overprinting garnet and clinopyroxene. Now, if you go in detail to these samples, what you can see here, you could see the plagioclase inside CPX, and along the grain boundary, you can see the growth of orthopyroxene within the CPX as lamellar. You can also see growth of rutile in this kind of rock, where the rutile is forming the grain boundary between plagioclase and clinopyroxene. We were not aware, while working on this paper, we were not aware of the significance of this rutile, but recent studies by Durga, and during her PhD, she is coming up something very interesting with this rutile. I cannot explain that more now, but keep an eye on the publication. Now, if you look at here, you can see plagioclase and orthopyroxene are seen as inclusion within the garnet. You can also see there are a lamellae of rutile within the garnet. This is very particular for high pressure assemblage. And if you look again on the matrix assemblage, the garnet having a resorbed grain boundary, CPX also having a resorbed grain boundary. In between, you form hornblende and plagioclase, amphibole and plagioclase, growing as symplectite or intergrowth between garnet and clinopyroxene. So this symplectite or intergrowth is actually showing the retrogression or decompression during decompression after the peak metamorphic assemblage. So if you look here, you can see there is a plagioclase. I think you can see the plagioclase inside garnet. But when you look carefully about what kind of plagioclase is this plagioclase is labradorite. So I think you know about labradorite. This is a mineral where you have a important feature called labradoroscence. So I'm a bit proud to say that this effect is actually published by Sir C.V. Raman, who was the director of IIC before. So actually the labradorite effect of this mineral is published from IIC long back. And then you look at the age of this rock. It is very important to find out how old is this rock. So we separated mineral called zircon and take a cathode-luminescence image. Why it is important? Because the cathode-luminescence image give you growth zoning of this mineral, or it is luminescent in CL, so it will give a different zones which enable us to date different zones of the same mineral. It is also important to make sure that there is no inclusions of other minerals in this kind of mineral. So if you get inclusions like apatite in this zircon, then it can affect your age. So we did a micro CT scan of the zircon. You can see it is very clean zircon with no other mineral inside. And what age it is giving is a consistent age of 2.5 GA or 2,500 million year old zircon with a retrograde age of not retrograde, I mean metamorphic age of 2.4 or 2,400 million year old. Now, if you look at other rock type like a hornblende biotite or charnakite, it's also giving you the same age of 2.5 GA and metamorphism at slightly younger at 2.4. So what it actually shows is these rocks are formed at 2.5 GA or 2,500 million year old, and then it is metamorphosed. Immediately after the formation at 2,400 million years. So this is the cross-section, real cross-section of Nilgiri based on, this is one thing which we learned during our BSc. We learned this with lot of difficulty and lot of unhappiness to draw cross-section of a terrain. I still remember that I was not very happy to do that. And it helps because if you draw the cross-section of a terrain, you can actually find out how the whole terrain evolved or how the whole terrain got exhumed. In case of Nilgiri, you can see there is a shear zone on both sides, dipping each other, and the center block, which is the Nilgiri block, is popped up because of the shear and dip on parallel to each other, and it is actually dipping towards to a point up to here. So it is like paste coming up of the toothpaste. It's popped up during the tectonic process. Now I will move on to BR Hills. BR Hills is situated next to towards east of Nilgiri block, where you can see it's a terrain where it's surrounded by shear zone on three sides, while the northern part there is no proper boundary. This was a problem. So many people counted BR Hills as southern part of Dharwad Craton or the high grade part of Dharwad Craton. But what we think is the former line or the OPS isograde was passing through the north of BR Hills. So it could be a low angle fault there, where BR Hills is interpreted as a separate terrain where high grade granulite and charnakites are present. Mainly charnakite, but towards the east and west of this terrain you get a lot of metagabbros and amphibole. So recent study by Ratish Kumar and others, several papers came out. Even after 2006, there is another paper came out in 2016. 2020, there is another paper by Ratish and others. They all say that this terrain is also formed during 2.5 GA crystallization and metamorphosed during 2.4 million year old. So again, the same result with Nilgiri. This terrain is also formed during the 2.5 event. Moving towards east to the Namakkal block, where George and Durga is working. What we can see here, this is also a terrain body towards the west of this terrain. So we recently find out Namakkal block is very similar to that of Madras block, where Madras block also consists of Charnakite and gabbro. Madras block also consists of Charnakite and gabbro, where the south of Madras block consists of metaplate, which is extending along the Salem-Arthur shear. The age of Madras block is again 2.5 GA consistently for all rock types, hornblende biotitanites and Charnakite, which is very similar to that of Namakkal block. If you look at a recent publication by Tanuja and others, we correlated Madras block along with the Gyeonggi Massif in South Korea and eastern part of the North China Craton, eastern part of North China Craton as one single block, which is a 2.5 GA configuration, and Antarctica was not with India during those times. It's not just our finding. Many previous publications also support this idea based on geochronology and geochemistry. If you look at the ages, what you can see here, this is consistently. Hello, can you hear me? Hello?
Yes.
Yes.
Audible. Yeah.
Yeah. Can you give 1 second? I'm getting disturbed with this internet thing. Just give me 1 second, please.
Okay. Yeah.
I don't know. I will turn Wi-Fi off. Can you hear me now?
Yes, perfectly audible.
Okay, good. So because I'm sorry that I'm getting disturbed with that popping up in the center. Okay. So if you look here, this is an age compilation of the whole South India, and Dharwad Craton all the way to crustal growth. And if you look at Dharwad Craton, it's slightly older than what we can see here, and slightly older than 2.5 GA. But if you look at Napier, it's slightly Napier complex metamorphism is 2.5 GA, but the crustal growth is clearly older. If you look at Namni Massif, this is North Korea, and Gyeonggi Massif is actually the southern part of South Korea. So it's south of Seoul. You can see it is exactly 2.5. And North China Craton, again, exactly matching with Madras block at 2.5. So India was together with these continental fragments geochronologically, but we need more evidence from paleomagnetic studies. If you look at Namakkal again back, again showing a high pressure metamorphism and 2.5 to 2.6 GA of the whole gray color part of India was part of South China, eastern block of North China Craton and Korean Peninsula through the recent publication. Look back to Nilgiri block. Again, Nilgiri, there is some problem. There are people who are expert in shrimp sitting in the audience. There are some problem with this data, which I know, but the age what we are getting is 2.5 GA again for the same rock type with that of Namakkal block in Nilgiri also. So my question here is, are all these blocks here, they are all a same block or different? The future students who are listening to this talk will answer that. Now, going south of this block, what we can see here is along the shear zone, you are getting 500 million years. But if you go to the north of the shear zone in Namakkal block, you never get a zircon growth at 500 million years. There is no zircon growing at 500 million years. If it is 1 month or 2 months back, I should be telling that there is no 550 metamorphism in this region. But now I could not say that because I know that there are people working on these areas going to say that 550 metamorphism is there, but no zircon growth. I still say that there is no zircon growth in this Namakkal block. but the 550 zircon are growing along the Kaveri shear zone and to the south. If you move to the south of Kaveri shear zone, you are getting typical ultra high temperature rocks or metaphysites which are metamorphosed at very high temperature, which is close to 1000 degrees centigrade. You also get saccharine quartz bearing assemblage along this center part of the Madhya block. What is the age of this rock? It is very important to say the age of this rock. This is 550 million years old by shrimp dating. You can see that there are two different age groups within this 550 group. What this age means? It is also important to check what is the timing of monocyte growth from this area. You can see that there are several ages given by monocyte. This is a chime ages. We are also getting several multiple ages in monocyte from the shrimp ages also, which is going to get published soon. This is work by Shasi and others in lithos, where you can see 530 million year old monocyte growth all the way down to 500 million year monocyte growth, which actually interpreted as growth of monocyte during the fluid infiltration and later resetting of monocyte. When you look at the cooling of this terrain, it is important to look at the potassium argon age of this terrain. One of my postdoc, during my postdoc, Professor Itea actually worked on potassium argon of this area. This is not directly done by me, but Professor Itea, who is working on potassium argon, find out the biotite cooling ages are significantly younger than the monocyte age. So monocyte, the lowermost age is 502 MA, while the potassium argon age is 512. So this is almost the same time of fluid infiltration, while the Kerala Consolite belt is much more younger at 462 to 451 million years. Nilgiri block also have a biotite resetting age at 600 to 700 million year old, which matches with the uplifting or the latest event along the shear zone, which is around 600 million years. So if you look at a summary of what we know from Madurai block, the Namakkal block is metamorphosed to somewhere around 1000 degrees centigrade to 20 kilobars. But my recent students are all against this. They think that it is a metasomatic event, including like Veni or all of them. They think it is a metasomatic event, not a regional event. However, the upcoming publication on South India, where we work on saccharine quartz granulate from Antarctica, Sri Lanka, India, and Madagascar. So this is a masterwork of Durga and others. This will say that this work is actually confirming the UHT belt is along the south of Palakkad Kaveri shear zone, and the recent work we are doing on Palakkad Kaveri shear zone, which talk about the metasomatic events because of this neoproterozoic UHT metamorphosis. Now I will move a bit more faster about the eastern part of India and the western part of India and the eastern part of Madagascar. So western part of India and eastern part of Madagascar is well correlated. The story of India and Madagascar correlation is well known. But why it is important? Why we need to study about that? If you look at the recent publications, which include me also as a co-author in some of these publications, there are several correlations for India and Madagascar. The first one, what you see here, is the first ever India-Madagascar correlation in 1979 by Kreitz and Primoli in Nature. In one single publication, you can see India and Madagascar was correlated in two different configurations. Why it is so important? You look at later publications, you get a lot of India-Madagascar correlation, where the Runatswara shear zone compared to KKPT to Palakkad-Kaveri shear zone to Moyar shear zone, you can move India and Madagascar to whatever way you want. The major reason for that is there is no stopper down there. So you can actually move these two continental fragments to the way you like it. And my students started working because each actually started working on this problem because the inconsistency in the recent publication about the same group of authors where they correlate in different ways. So before going into the details, we should go back to the normal concept of plate tectonics, where what are the components of a plate tectonic? Keep this in mind. You need two continental fragments. You need an arc. You need a place where all your sediments can be deposited. You should get a set of ophiolites or high pressure rocks. Then you should close this ocean, and all this evidence or most of this evidence must be preserved along the line of contact of these two continents. That we call suture zone. So along the suture zone, you are expected to get evidence for an arc, evidence for sediments, evidence for ophiolites, high pressure rocks, all along the suture or in and around the suture between two continents. Now, let us see whether we are getting these things here. When you look at this continental correlation, where to start? So when he should come to me, he asked me why the shear zone in Madagascar is moving towards east like this and suddenly disappear. Then about 100 kilometers south, the same shear zone coming inside. What happened to this shear zone? Actually speaking, I don't have an answer at that time. I was thinking where this shear zone went off. So what we did, we asked the author of this paper, who is Brand Lindley, we asked him what happened to this shear zone. Then Brand answered us, well, this shear zone must be disappearing in the shelf. Then we should ask back a question, what happened if the shear zone is in India? Because if India is here, if you can find out the same shear zone in India, then that will enable us a precise correlation between India and Madagascar. So we start looking at two potential areas. One is Karwar and the other is Coorg. So Karwar and Coorg area, you can see that there is a shear zone which is starting from its north, moving towards east, and then again coming back and disappearing. Again, this is coming here inside and then disappearing. So where this shear zone goes, it is very important to check. So first we will check this region, which is Karwar. You can see the rocks around Karwar are all trending northwest, southeast. Then towards the center part of it is north-south, and then it is trending northeast, southwest. Moving towards the shear zone area, you can see the lineaments are getting dense. And again, away from the shear zone towards west, there is no proper lineament orientation. The lineaments are oriented in different ways, indicating this could be a igneous rock, where no proper orientation. This could be either metasedimentary or a metamorphic rock, and definitely along the shear zone, you are expected to get metamorphic. When you go to the field, what you could see, the pink region here is actually the Deccan Traps. You can see here, this is the Deccan Traps which is still remaining just north of this terrain. Then south of that, this is the blue lineaments are the Darwar Plateau here, and the gray part here is actually this region, the brown color region, which is mainly sedimentary rock, unmetamorphosed sedimentary. We were expecting metamorphosed sedimentary rock, but these are all unmetamorphosed sedimentary rock. Moving near to the shear zone, you start getting metamorphic rock, but metamorphic sedimentary rock. Most of them are actually equivalent to these sedimentary rock. What we understand that these sedimentary rocks get metamorphosed along this suture. Now we will see one by one. I will come back to this Karwar block later on. When you look at the metasedimentary rocks of this region, sedimentary rock of this region, you can see that these are mainly quartzites. Then there are vertical lineations in the schists or pelites or slates. There are also ripple marks still remaining or still preserved very well. Dendrodine formations are slightly deformed, but they are not metamorphosed, no metamorphic minerals. And when you move to the east, you can see a low angle contact between Dharwar block or Dharwar pattern and the shelf region or the Sirsi shelf region. When you go to the metamorphic rock of this region, if you go close to the shear zone, you can see the quartz grains are getting deformed. But away from the shear zone, they are well-rounded quartz grains preserved in the sandstone. Same to the calcite. If you look at the limestone, they are unmetamorphosed, but when you go near to the shear zone, they are converted into marble. Now, what is the age of this rock? As normal as any other person, we went and separate zircons from this rock and date it. Zircons are a mixture of positive epsilon hafnium and also a negative epsilon hafnium, which shows that they are from multiple sources, either from a mantle source or from a crystal source. But the sad part is, these zircons don't have any metamorphic event or any metamorphic overprint. You got age all the way from 2.6 to 3.4 GA. There is no consistent age for this one. So what we understand, we got sediments coming from 2.6 GA to 3.4 GA from different multiple sources, which is matching with the hafnium isotopic signal. Now you go within the shear zone, you are getting a not highly metamorphosed, but high pressure garnet bearing rocks at the north and quartz phengite schist rocks from the south. So these are metamorphic rocks you can expect along the suture zone in a normal tectonic system. What are these rocks? You can see that the garnets are euhedral. There are typical high pressure, low temperature growth of garnet. This is a calcium elemental mapping of the garnet. When you look at the marbles, they are all recrystallized calcite, and towards the south you get chlorite quartz or phengite quartz schist. Now, looking at the phengite chemistry, you can see that they are comparable with experimental phengite at 15 kilobar and 800 degrees centigrade, and also worldwide phengite composition which matches with the metapelite phengite along the suture zone, and they are not matching with the eclogite phengite along the suture zone. So these are more likely to be a suture zone sediment, not eclogite. Now when we look carefully in this rock, you can see there are small inclusions of kyanite within the phengite. These small kyanite inclusions within the phengite actually push our pressure to much higher pressure to 19 kilobar, but the temperature is far lower at 500 to 550 degrees Celsius. So this matches well with the suture zone setting. And what is the age of this rock? We did shrimp dating of these samples. Again, we got only 2,600 to 3,400 million year old zircons. But if you look at this zircon cathode luminescent image, there is no growth of or overgrowth or metamorphic overgrowth for this zircon, unfortunately. So we could not date a metamorphism directly from zircon in this sample. However, if you look at the lead loss of these zircons, you can see they are all going down to 1,000 or 1,200 million year spot. No one will accept this. But we could date the same sample using potassium argon phengite, because the corrosion temperature of phengite is somewhere around 550. So what we could find here is that age is 1300, consistently 1326 or 1385 million year old, which match very well with the dead loss age of this. Hence, we conclude here that the metamorphism . Now, what is in this region? It's also very important, because we were expecting an arc, because you can see the shelf. Now the suture, next to the suture, what you are expecting is an arc. We were expecting an arc, because in the field, what you can see is TTG and amphibolite, angular blocks of amphibolite within the TTG. Perfect. There is no orientation, unmetamorphosed sample. But unfortunately, the date what you get is older than the metamorphosis. What you are getting is 3200 or 3200 million year old zircons from this sample. And the amphibolites are around 3000 million. You cannot get a 3000 million year arc for a 1300 million year subduction. What is this? So this paper is very recently, 2 days back, accepted in American Journal of Science. You can get this paper soon online. What is the reason for 3000 million year old crust next to a 1300 million year old suture? We don't have an answer for that. Where is the arc? Without an arc, we cannot get a clear answer. The same, if you look at the neodymium or hafnium isotopic signature of the samples, they are having a juvenile crustal signature, which is also not accepting the idea of an arc. What happened to the arc? We were looking for an arc signature rock along or just to the west of the suture zone. When you look at the rocks along the west of suture zone, you get a Bondla complex, or you got ultramorphic complex where chromites are present. Chromites are a kind of petrogenetic indicator, which many of my students may not accept, but yeah. When we did this study, we considered this as a petrogenetic indicator, and what we get here is clear indicator of an oceanic arc. So this is the only evidence what we have that there was an arc preserved, but the whole block here was not an arc. This is actually the continent, like Dharwar Plateau. This is another piece of continent which is collided, and the arc was almost eroded away. Only remnant of arc what we got is the ultramorphic complex, which is just a root of an arc, but not exactly the full arc. Now, we don't know the age of this arc because it is difficult to date this ultramorphic rock. There is no zircon in such rocks. So what we did is we assume that this arc is part of this subduction zone system. But we also need to know what is the age of the easternmost part of this terrain, which is Dharwar Plateau. Just east of Sirisi Shelf, what we got is 2.6 GA or 2600 million year old rock. So this is significantly younger than what you are getting around the Karwar region. Karwar is around 3200 million. Putting together all this idea from several publications, what we could find is a 2.6 or 2.57 million GA old continent collided with a 3000 to 3200 million year old continent. In between, you got a metamorphic zone of 1300 million years, where there are blocks of arcs enclosed along with the metamorphic rock. Then you get a sequence of sediments which is moving away from the suture. It is getting unmetamorphosed, and finally you are getting sedimentary rocks which are completely undeformed. So this is a perfect cross section where you can see a subduction which is happening towards the present day west along this suture zone in 1300 million years. So this is the mesoproterozoic suture which we proposed, but then what is going on along this Coorg suture zone or along the Coorg? So Coorg, what we get, or the other people like Santosh and others published recently, this is our data where we also get 3000 million year old crust, which is very similar to what we saw in Karwa. However, along the suture zone towards the north or east of Coorg block, what we are getting is garnet bearing or high grade metamorphic rocks. This is different from what you got in Karwa. Here what you are getting is garnet clinopyroxene bearing mafic granulite. You are also getting garnet and kyanite bearing rocks and garnet quartz symplectite, which is very similar to what you are seeing in Nilgiri or Namakkal region. So these high grade metamorphic rocks are metamorphosed fairly high pressure around 13 kilobar, but temperature is very high, around 850 degrees centigrade. In Karwa region, what you get is around 500 degrees centigrade. Now, looking at the age, the laser ablation ICP-MS age of zircons from this rock, they are giving as expected 3200 million year old. Unfortunately, here also you are not getting zircon overgrowth, but the lower intercept age is going back to again 1100 to 1200 million years. However, if you look at the potassium argon age of quartz of feldspathic gneiss, the biotite potassium argon age, which is slightly older, 900 million years. Note, in this kind of rocks, the potassium argon ages are actually the cooling age, not the metamorphic age. So the peak metamorphism may be slightly older than 900 million year old. So we agree that the 1100 million year old event is actually the overfunding event of this suture. The rocks within the 3200 million year rocks, what we see inside the Coorg region, which is very similar to what we see in the Karwa region, euhedral plagioclase, euhedral orthopyroxene growth, no signs of metamorphism. They are clearly 3100 or 3200 million year old juvenile crusts. So this is very similar to Karwa crust. This is unpublished data. We haven't published it yet, but there are several publications from Coorg region showing similar results. What you see in Madagascar, if you look at the rocks from Madagascar region along the Ronmina or Alatora complex, which is within the northern part of Madagascar, you can see a similar kind of rock to that of Coorg. Exactly same, euhedral garnet growth. You have garnet CPX in association or orthopyroxene olivine bearing ultramafic rocks where there are chromites. Chromite chemistry is very similar to that of Bondla R chemistry along the shear zone. So this is matching very well with other places, either Coorg or Karwa. But if you look at the normal mafic granulate, you can see there is a growth of quartz garnet symplectite along ilmenite or plagioclase. When I work on this, when Isha worked on this region, we were thinking this is very strange. But recently, we realized that this is very common in South India. We have a lot of samples with similar kind of textures along Namakkal, Bhavani Sagar, Nilgiris, everywhere you got the same, exactly same texture. This is very different from a normal garnet clinopyroxene bearing rock. This is from Sri Lanka, where you have a clockwise PT path. So if you are seeing exactly opposite to that, do you think it is upside down? I don't know. And most probably, this is showing a counterclockwise PT path where garnet is growing, high density minerals are growing after the breakdown of orthopyroxene and plagioclase. Very much possible. Now, age of these rocks are very similar, 900 million year old zircon overgrowth, and the core ages are somewhere like 2500 or 700 million year old zircon. Now, Ratish and others look into the elastic thickness of this region. He is a geophysicist basically who started working on rocks after joining with me. So you can see that the crystals, there is a thinning or a thin crust along the eastern part of Madagascar and western part of southern India. What happens if you mix them together, if you put them together? You can see it exactly matched. So this thinning is actually connected to the pulling apart of India and Madagascar, which actually match with the Moho thickness and the correlation proposed by Ishwar and others based on the geology. So we propose a new correlation here. This is the Mesoproterozoic suture, 1300 million year old suture, which is running all the way from Madagascar, entering into India to the north, to the east of Karwar, again going back to Madagascar, and then entering into Coorg and ending up in to the north of Nilgiri block in Moyar shear zone. When you look at all published ages along the shear zone in this region, so this pink color line is the shear zone. If you look at the granite ages, you can see that the ages are getting younger and younger when you move towards the western side. The reason for this younging is interpreted or speculated as a reason of subduction. So when you get subducted, the northern part of the Karwar block and the Dharwar crater might be collided first, which is a soft collision, and eventually closed to the south. And when it is eventually closing to the south, you get metamorphism becoming young towards the south, but old to the north. Also, this is connected to the amalgamation of Rodinia supercontinent and what we think is why we are getting high grade rocks in Coorg and why we are getting low grade rocks along the Karwar region. The reason what we think is the separation of India and Madagascar happened along during the reunion hotspot. Then India started moving towards the north, and while India was crossing the equator, it should be the highest rate of erosion. The highest rate of erosion might be here, which is somewhere like 38 million years ago. But the Deccan Traps was as old as 65 million years just before splitting or just after splitting from Madagascar. So the Deccan Trap cover on the north actually was extended to the south, which is eroded and taken away when India was passing through the equator. While the Coorg area was not covered by Deccan Traps, so the low grade upper part of the crust was shaved away, and what you are seeing in Coorg is the lower part of the middle crust which is exposed in the Karwar region. This is just a speculation. This is not published anywhere. So we have more confusion than conclusion. We still cannot answer many of these questions. Yeah, so you get more confused than what you learn something. So I hope many of my students will answer these questions. And I should thank all my students, funding agencies, and my teachers or faculties who helped me to reach up to here. Thank you very much. Hello.
Thank you, Sajeev.
Hello. Yes. Hello. Yeah. Can you hear?
Yes, yes.
Okay.
Now question time. If you are having any questions, you can ask.
Yeah, there are people raising hands. You can. Hello. Yeah, go ahead. Anyone who wants to ask questions, please go ahead. I can see Durga raising hands there. Hello. unmute yourself and ask questions.
Durga has raised her hand. Where she is? Durga?
I think she can't.
There may be questions from others. Let us see that. You can also put a comment. Durga, are you talking? It is not clear.
Yes. Hello.
Yeah.
Yeah. Yeah, please ask.
Hi, Sujit.
Yes.
I have got a question that most students in the bachelor's would like to know,
Yes.
and that is, how would our geological research or
Yes.
our research on archaeotectonics or
Yes.
present day tectonics would help them in the understanding of the present day, not just geology, but then also how it can have an impact on our present day, society, or how it will impact on our day-to-day life.
Okay. Okay. First thing, this is one thing we know. Hello. Can I go ahead?
Yes, yes.
Yes. So the first thing, tectonics do have a lot of impact on present day climate. So learning past tectonics is very important to know about the present day climate. So this is directly or indirectly connected to the present day climate, first of all. So if you look at this slide itself, the paleotectonics and paleoclimate is directly connected. That is one way you should put this in. Another part of learning about rocks is it is directly connected to resources. So what we are talking, say for example, like chromites, they are connected to resources. And most of the gold or hydrothermal mineralization is connected to tectonics again. Say for example, if you look at Madagascar, this is a place where you got a lot of gemstones and gem mineralogy. However, if you look at South India, we don't have much. We don't know much about the gem mineralogy. Where these gemstones are, either they are eroded away or they are still there. We have to find them off. So studying isotopes or isotopic relations between continents actually help economic geology and national mineral resources. So these are two places where you can directly apply. And more than anything, don't expect that every science you do will be connected to day-to-day life, because this is add-up. When I start doing science, I never thought that I will be working with a geophysicist to work on something called continental correlation. But geophysics, they use it for present-day geophysics. And Ishwar, who is from a GIS background, who used the GIS application for continental correlation. So these are all interconnected. So when you look at science, don't think that it is just one small thing. So it will be connected to several different things inside. Yes.
Can I ask another question?
Yeah. If there is no one else, you can.
Yeah.
Just wait for a second. If there is someone else, I will take another question. Then I will get back. If there is any other question, otherwise I will ask.
Let her ask. Let her ask. We will find some others later.
Sure. Please go ahead. Yeah.
Yeah, it's just a little bit different from your previous answer, but it's it's a question in the similar line,
Okay.
which is, why do you think that young students or like people who have finished their 12th grade actually take up geology or pursue geology? And how do you think that is going to benefit the society or
One thing.
a nation or in a global level? Thank you.
Okay, I will ask a question. I will ask a question back to the audience. If you take physics, how is going to help them day-to-day life? Or if you take chemistry, how is it going to help them day-to-day life? I think geology helps students more than physics or chemistry in day-to-day life. One, if you just take an undergraduate in physics, chemistry, or geology helps more. Okay, than physics, because I still find difficult to find out why you should understand the momentum of a body which is in your concept. Yes, there is application. There is application directly. Say, for example, in automobile industry, there is directly application. But very few people have very few people know about this, right? So geology have lot of application in that sense. Now, if you ask why a student should take, I know where the question is going. There is a big drawback in worldwide acceptance to geology. I'm not a philosopher to talk about that, but if you look at the worldwide geology, geology is not a subject in your school. Geology is not a subject in your most of your plus two. Ajit may be here, or there are few places where you have geology. So in general, you are not actually teaching geology from the school level. Then what you are doing? What we are doing is we are suddenly injecting geology at a level where you are already reaching to a decision. So very few students, like say for example, students who are entering to IIC, they are taking geology at year 3. Not even geology. They are taking earth and environmental science at term third year. This is not good. Definitely not good. What I think, geology is also a subject where you need to learn right from the school days. It is not geography and geology is not same. It is different. There should be a curriculum change, which I am not the right person to do it, but we must incorporate geology in the school. Now, application of geology do have a lot of application. If you really look into one of the recent papers where I haven't included that, where we work on the weathering aspects of the rock. The nutrients to the soil is given by the rock. So soil science is something which people never care. Soil is basically as important as climate. You cannot replace soil. You cannot replace or re-inject nutrients into the soil. We are damaging soil dramatically. Okay, I'm not a person who would like to say to make philosophical talks, but it is a time for us to learn mineralogy. It is time for us to learn soil science, weathering, and rocks. So if you don't know about rocks and mineralogy, you are not going to learn about its weathering. You are not going to learn about the element diffusion and element mobility in the soil. So one way, if you are not learning geology properly, I can tell you most of the engineers will hijack geology and they will take it into a different direction. And that's not what we want. So we should be confident on learning mineralogy and geology, so that we will directly, the question what Durga was making, where we are going to apply this. Every science, it is your job to find out where you are going to apply it. 1. 2, there are several areas of application which we are not looking into. Say for example, how many people work on weathering? Not many. Why? Because you don't know mineralogy itself. then you cannot work on weathering. You don't work on how many gemologists are there in India, how many mineralogists are there in India. I don't think there is even one. And there is no gemologist in this country. We don't have a gemologist. Gemologists are basically people who are not educated. They know about garnet more than what we do. So these are areas where we need to emphasize, we need to have a policy making so that there will be definitely applications for geology. Geology do need a lot of application than oil and gas. And where we should do is, yes, we are the people who should do it, not instead of blaming we don't have an application. I think it is time for us to do that. Thank you. Hello.
Yes, we can pick up few more questions.
Yeah, please go ahead.
Yeah. You can also type the questions in the comment box or chat box. It seems there are not much questions. Durga again raised hand. Okay.
Hello, Sujit.
Yes.
It's not really from me. It's from my friends
Colleagues, yeah.
who are doing PhD at the Australian National University.
Yes.
They would like to ask you a few questions, if you don't mind.
Sure, if I can answer, I will.
Yeah, sure.
Hi, Sajeev, it's Naina.
Yeah.
I wanted to know what sort of geophysical data you're using and towards what end, like what sort of data you're using and for, like, what's the reason behind it? Are you using gravity or
So what we use is present day crustal thickness data, but not me actually. It's my postdoc Ratish. He is a geophysicist basically. So he actually take the present day crustal thickness data. Then what we do is using GIS, we compare that with the present day data of Madagascar. So if you, to my understanding, what they do is, if you look at the blue color region, can you see my cursor? Hello.
Yes, we can.
Yes, we can.
Yeah. So if you look at the region here, the blue color region, this is the dotted line is actually the boundary. So these are present day crustal thickness maps. You just put them together. You configure it with the paleo coordinate. So what we use is the rock magnetic data, paleomagnetic data to get the paleo coordinates. Using that paleo coordinates, we georeference them to a paleo configuration where the thickness accidentally match. It is not like we match them. They accidentally match, shows that the crustal thinning is because of the extension between India and Madagascar. So that is how we use the either the elastic thickness map or the MOHO or the gravity map for this purpose. But basically, Ratish is using it for a completely different purpose, the crustal thickness studies on a geophysical background. But here for this particular paper, what we use is for that purpose. So I'm not a geophysicist to use the geophysical data, but my postdoc actually used.
Thanks, Sajeev. Are you using this data to look at any of the structural information like presence of faults or shears or anything else?
You mean the shear zones?
Yeah, like shears or faults or
Yes.
This
study we are not using. There are several studies based on gravity anomaly. I remember where the shear zones and the crustal thickness along the shear zone and the magnetic anomaly along the shear zones were studied, but we are not doing it. I mean, I personally was not doing it. There are people doing it. There are publications from South India where you get this information.
All right. Okay.
Yeah.
That was all I had. Thank you. Thank you, Sajeev.
Thank you.
There are few more to come, and Jasim is there. Jasim?
Yeah, I'm here.
Yeah. Something you may have to comment on this one, or some doubts will be there.
No, not really. Yeah, I'm not the person to comment on this because I mean everyone might know because I already deviated from the subject, so currently doing with high pressure experiments.
Okay.
So I'm a bit how to say.
Yeah, he
I
is
don't-
working on strange minerals.
Exactly. I mean the things which Sajid has shown in his slides, like mineral assemblages, rocks, I used to make all them in my lab. That's the difference.
So he artificially make minerals in the lab.
Lab, yeah. So
But what minerals he is making is not the minerals we ever study, not in dance.
yeah, actually, yeah, especially on mantle and I mean in core regions. So that cannot come up to, I mean, brought up into the surface level. So yeah.
Anything else?
Yeah, we will
No.
take from Akhil.
Okay.
Is there.
Yeah.
Hi, sir. In the elastic thickness map,
Ah.
as far as the geophysical evidence, we can see some that CB, KB, and MC. If we consider those three things together, we can see some fold-like structure. Maybe in earlier time, it may be. Can we refer like that, or is there any geophysical evidence for this?
Which one?
this BSC
Can you talk little slowly, please? Again?
Yeah. Yes, sir. Yes, sir. So if we come, yeah, sir. There KB is there and MC and CB.
Yes. CB. Okay.
KB,
Yeah.
CMC.
Yes.
And bounding that there is KSZ,
Yes.
MSZ,
Yes.
and BSZ.
Yes.
So if we see like if we combine this image together, so we can see one fold-like structure starting from KSZ to running towards
Yeah.
BSZ.
Okay. So geophysical results, there is no much evidence, to be frank, to correlate between shear zones. Okay. For correlating shear zones, we have more. Sorry, we have more evidence going back. I don't know where that slide was. So if you look at the structural map of the region, we have a lot of regional structures which is extending from there to South India, but we don't have a geophysical. We never attempted a geophysical correlation between these two terrains.
Okay.
Yeah, we never. So I am not sure whether I answered your question correctly, but yeah, we never attempted a geophysical correlation. The degree of weathering and erosion is different in each continental fragment, right? So I think
Yes.
it may be difficult to get a proper anomaly map which can be correlated. I'm not sure about it. I mean, to my limited knowledge with geophysics, I think it is difficult.
Sir, to find out this, to find out this elastic thickness map, any gravity or magnetic data has been used?
Yes.
Okay.
But yeah, so I do have a very limited knowledge on geophysics. But if you have serious questions, you can actually contact Radish also.
Okay, sir. Sir, could you please share email ID?
Sure. Yeah, why not? You send me one line email, please. Radish is there in Kusat. He just came back from. So he was doing a postdoc in NASA. So he just came back I think a month back.
Okay, sir. I will contact.
You can definitely contact him. I will just put his email address. You can also contact Ishwar if you wish, who is in IIT
Sure.
Kanpur.
Yes, sir. Please send his mail ID also, sir.
Yeah, I will send. Can anyone of you? I'm trying to find out where the chat box is. 1 second. Yes. No. Hello. Hello.
Sir, you are audible, sir.
Yeah, just 1 second. I'm trying to put. One of you, can you please put some message in the chat box? Anyway, I was having the chat box, but it just disappeared. So this is Rajesh. Email. You got right?
Yes, sir. Got it, sir. Thank you, sir.
Okay. Anyone else? I saw Durga's hand, right? But I will take others' question, then I will get back to you. Otherwise, people think that I am arranging questions. I am good for doing it. So Brijesh, how are you? I don't hear anything from you.
I will be coming to that.
You will be coming to that. Okay. I know that you will have something. So I am actually, I'm sorry that there was some disturbance in the beginning, because this pop-up window is really disturbing me because it's just coming up. So I'm sorry, the first half of the talk was like, I got disturbed really. Then I suddenly realized that, okay, just cut it. If it is too disturbing, it is better to just cut it. So anyone else, or else I will take the last question from the. Hello.
Hi. Hello.
Yes, yes.
It's nothing much, but I really enjoyed the talk, and you have always been an inspiration. And I would like to thank you for the presentation, and yeah, that's it. Like I just wish that a lot of MES Ponnani students get to geology and do a lot more. So I just wanted to thank you, and thank you for the opportunities that you have provided for us. Thank you very much.
Durga, you will be the next speaker.
I will come.
Durga.
That she will not get, she will not hear that.
Oh, so, yes, ma'am, I've heard that. Thank you. I did hear that.
Okay.
So
We'll call you.
I'm going to attempt that too.
Sure.
Yeah, I was inspiration. I want to show this last day. You know how difficult it was for the faculty to manage us.
Sajeev, I'm really sorry that you were so notorious at MES Ponnani. Like,
No, I was not.
You were really
I recently discovered that I know dancing.
But you are supposed to inspire the students who are there
Yes,
at the
I
moment.
am. See, I can inspire only what I know, right? I cannot inspire with what I don't know. What I know, I am inspiring.
Then better go for crowdsourcing, Sajeev.
Pardon?
Crowdsourcing.
That's what I'm telling. So I can do, I can inspire only based on what I know. So anyway, thank you very much. Thank you all for this opportunity. I always enjoy giving talk in my own place where I learn geology, and I must thank the people who had a difficult time when I was there, especially GK sir, Prabhar sir, and Ice teacher. It is not joking that they had a hard time. I mean, they really had a hard time. Okay?
No. It was pleasure.
They had a hard time. I mean, maybe they are still having a hard time because I know what is coming from there. Okay, so I at least know what is coming from there. So they are still having hard time, I think, unfortunately. But one thing I can tell you, the products who are coming from Ponnani, actually, they are, I mean, for a fun, I can show this kind of things, but at the same time, if you look at that photo, I cannot believe myself. Other people, they might be in good position too, which I don't know because I am not in any of this social media. But yeah, I'm surprised to see that, I mean, in one single batch you got that many people, and they were all not, except Babu and Brijesh, none of them were extraordinarily good. So what I want to tell students, students in general is there's no, I mean, need not be extraordinarily good, because in our study list, the people who have a complete notes or complete study material is only Babu and Brijesh. So, but still others also manage to, and I'm happy that both of them are also in good position. Babu and Brijesh is also in good position, and some of us also managed to reach good position. And I assume that many others are also, most probably. I mean, if any one of you know that where they are, please let us know. When I find this photograph, I find the importance of looking into those things. So it is important to know that. Hello? Yeah, that's all from my side. Thank you.
I think Dr. Manoharan sir is there. HOD Government College, Kasaragod. Manoharan sir, anything to comment?
Actually, I couldn't listen to the total seminar because I was in a Viva, BSc students Viva was running, and afterwards I was on the, actually I owned this one but I couldn't listen. I was participating but I couldn't listen properly, but last fag end I was listening so that I couldn't get clearly what are the topics covered and.
Okay, sir. Okay.
Okay.
So, anybody else?
The students are attending this talk?
Yeah, many are there. UG and PG students are there.
Okay. I hope you don't understand anything, right?
That's why the grade of metamorphism was so high.
Yeah. No, I mean, if they understand, I am worried. I mean, at least one student should say that I don't understand anything.
They're afraid of Aisha teacher, you know that.
Yeah, I know. I know.
Oh my God.
I know that. You don't have have to be afraid of higher status, especially final year students. So I will tell you then another thing. What really happened is I started my talk and nobody is like, there is no feeling in students' face. I don't want to tell because you know where it is. Okay, some of you know all that. And I was like so difficult to talk because when I am talking in English, I don't know whether they are getting it or not. And suddenly I asked them in Malayalam, are you getting it? So it's in the Kerala only. Are you getting it? And there was one guy who say no. That guy happens to be with me later on. Okay. Anyway, so he was brave enough to say that. And that's the only Malayalam talk I give ever. And I managed. Okay. I managed to give my talk in Malayalam. But actually, there was lot of questions from students. I was so surprised. And they were good quality questions. So anyone who want to ask a question in Malayalam, you can ask. I know Malayalam. Kurch. Still. Okay. Anyway. Thank you then.
Okay, Sachit. I think there will not be any more questions.
Yes.
But it was really, we had gone back some 25 years back. BSc mark list, we will get a date 18th July, 3 more days. Yeah. So it is a Silver Jubilee commemorative lecture for our graduation.
I don't know.
I'm just putting it in that way, no problem.
Because I realized that it is not 25.
20, yeah. Exact time after graduation.
Okay. Yeah. MES, get rid of us.
Yeah. And the one thing I always remembered when I was in Mysore bus stand on the way to Mysore University there was a color lab just near to that Maharaja Hotel. You may be remembering that well. That is why I told you go for crowdsourcing.
Yeah. Yeah,
okay.
It was there.
Okay, nothing more on that. So it was really happy and nice to be with you for the last 2 hours. And we are very much grateful to you for that. And as our principal told, even otherwise, we will be getting you here. And we had you with us for that Golden Jubilee lecture series. Sure. And you made a beautiful presentation on that age and beauty of frogs. I still remember that.
Okay.
And so as you told, it is a time for geology actually, because with one over the other disasters are coming and the resource crunch is there, people are looking more for geologists. Yes. And the subject as well. So we are trying our best. We had a movement to include geology in the high school curriculum in Kerala.
That is true. Because, see, for example, if you look at a country like Japan, they need geology in every step.
Yeah.
Say, for example, if you want to construct a road, if you want to construct a house, you need to have a geological survey. You need to have analysis for. There are private people who do analysis for.
Yes.
Students who completed PhD can take a job by themselves to do this kind of analysis.
Yes.
Making thin section is living in Japan.
Yeah.
And here, you can't. So, I mean, this is a good point where you have to have geology to that level. Then only you will bring a lot of useful geology.
Yes. And actually, people are looking more for that now. And not much information is available, especially in Malayalam. So people are very much fond of that actually. So if possible, if time permits, you can put a few points and we can translate that into Malayalam and we can publish it somewhere so that let it reach every corners. So that will help the administrators as well to take some decisions of inculcating this.
So I will be happy to help in that kind of level if I can.
Yeah.
In any such level, because it is, see, if administrators don't know about it, we can't succeed. So we have to teach them with things. I mean, one small example is like once I show a structural lineament map to a principal secretary. So this principal secretary was uncle of my student. So it's George's uncle, who was principal secretary who is in charge of this Vision portal. Okay, he was what's his name? James Varghese. James. He retired actually. So it's during the last government time. Okay.
Tom Jones?
I think no, not Tom Jones. This is Achyutanandan time actually. Okay, Achyutanandan time, I think. Anyway, so I was talking to this guy, and he suddenly stopped me and said that, oh, there are a lot of fault running through the the dam side.
Okay.
Why? And my discussion was completely different. I was talking about geology. Okay, the rocks of that region where George is working. Okay. Because his uncle I saw this thing. And he was suddenly stopping me and saying that, okay, Idukki Dam, there is a fault running. Why is that safe? And that's the first time administrators know about it.
Mm-hmm.
Okay, so those who have access to administrators or ministers or people like that, it is good to educate them and tell them that it is important to incorporate subject like geology into the curriculum.
Yeah.
Okay, because the question what was raised, where it is useful, is very important, because if we cannot give a real cross-cutting answer, it is difficult in next generation to use a subject. That is same for physics, same for chemistry, but same for any subject, because people need application.
Yes. So this is the right time, I think, as you told.
Yeah, I will be ready. I will be ready to invest time on such things.
Yes,
definitely.
Definitely, we will be in touch with you.
Yeah, you can send me an email or just call me anytime.
Definitely. So officially, we will be winding up this IIC Impact session.
Yes.
So let me come to my duty. Okay. So it was really a serious talk, and some bits of this I could hear to your talk again on that GSA Geological Society of India monthly talk, May 15th or so you gave. So I could attend that fully, and it was.
You were there. You were there.
I was there. And so it was a continuation to that actually. So it was very nice, very interesting, and I don't know why our students missed it. I mean, without anyway, Durga helped us, and as an alumnus, we can point her as our student. So that was good. And so first of all, I wholeheartedly thank our beloved Dr. Sajeev for having taken our invitation and for spending your valuable 2 hours with us. Thank you so much on behalf of MES, on behalf of Geology, as well as on behalf of Institution Innovation Council. Thank you. So
thank you very much. Yeah. Thanks for inviting.
Yeah. So the president of the function was Dr. Ajim P. Mohammed, our principal, who was very much instrumental in organizing this kind of innovative ideas, and this webinar was also his brainchild. So I thank Dr. Ajim P. Mohammed for his presidential address and for his presence. And our own Aisha teacher. So as Sajeev told, I was just thinking in 1993, the first lecture that teacher gave us was on groundwater. You may be remembering that. At that time you were in the class. Okay. So even otherwise, okay, and that were the real time what we enjoyed, and that class. And I was just thinking when you were showing those photographs, so the pain that they were taking, especially teacher because
I never forget teacher's stratigraphy.
Yeah.
So that's something which I never, because I was trapped in an exam class. no one told me that day it was an exam. Otherwise, I could have escaped. But
Yeah.
I was trapped in that exam, and I could not even write one line. So I just write my name. So and no, not even I still remember where I sit. Okay, because it was a place where I could not jump out of the class.
Yeah.
So
That's side bench.
and it is like so teachers can enter from one side and then you cannot go out, right? The second year class.
Yes, yes.
Second year, I think. Yeah. So that exam I will never forget. I mean, not different from other exams, but that was accidentally I was inside.
But fortunately, there was no internal marks at that time.
Yes, true, very true. Very true.
So it was all very
Yeah,
good.
because now stratigraphy is becoming very important. Like what I was talking.
Yes.
That shelf region. We are writing I mean, not me actually, one of my colleagues, but I am a co-author in that work.
Yes.
We are working on the stratigraphy of that region. So whenever we are using stratigraphy, this thing comes to my mind all the time. To be very frank with you.
Okay. It was really nice. Okay. So I thank officially as a part of this, I thank our beloved Aisha teacher for welcoming our own Dr. Sajeev and for being with us for the last 2 hours. And then I thank the IIC President, Dr. Jairam, then all my colleagues, Dr. Sri Srijit, and our friend Dr. Sri Ajit Kumar, Dr. A.N. Manoharan sir, and many of the students, researchers, and teachers from all over the world, as teacher has put it rightly, and our own Mr. Jasim, Ms. Durga, Nidya, Adira, Tanuja, and all our beloved ones. And I take this opportunity to thank each one of you for being with us for this IIC webinar. And hopefully we will be arranging more, and a standing invitation is there, especially with the Department of Geology, and you are all welcome. And we encourage gate crashes than normal comings. Okay, so thank you all. Thank you very much. Okay, teacher, over to you.
Thank you, Sajeev. It was a wonderful session, as always.
Thank you.
A nice time to remember your classes, your study tours with you. It was an unforgettable incident. It was a wonderful trip. I always remember with your batch. It was a wonderful batch.
I am expecting that teacher will not go to details.
No. That we can have personally.
Bridget's face, I could see the tension because what is coming next?
No.
I was thinking that you are going to release all those Kemmangudi photos and all. Then by that time I would have escaped.
I thought
photos and more than
he's having all collections. I never thought you will exhibit those photos.
Yeah, I recently discovered that I have all the negatives with me. So that's a new discovery. I mean,
Yeah, we have to be careful. Aji is there.
Yeah, that is.
I think Ajit left afraid of that one.
Ajit told me that he is having some meeting after in between. So he said that he will be leaving.
In fact, actually, he is afraid of your photographs.
Yeah. No, I asked him for some other photograph. He said that he is not having any photos. I know it's a lie.
We will raid his house.
See, another good thing is now everyone have a mobile carrying for camera with us.
No use.
You remember those days, like we collected money to take photos. You remember those stories, right?
I remember very much.
Yes.
You were the treasurer in that too.
Yeah, because I was secretary. So.
That's right, teacher. That is why that only one scam is enough. That Maharaja's studio.
Yeah.
Anyway, okay. We can meet again.
Yeah, thank you very much. Thank you for inviting me.
Yeah.
Thank you.
Thank you so much. All of you, thank you very much. Okay.
you.